What's up, YouTube? It's your boy JOSHABRAHAM. And according to the timetable, I should be starting with the equations. I just have to memorize the equations involved. That's it. That is it. So that's gonna be cool. I wrote tool 2C, right? Auto catalytic reduction. Reduction of potassium permanganate by oxalic acid to H2C2O4 plus 6H plus gives 2Mn2 plus 10 CO3 CO2. Fuck. What is CO3? God damn it. Plus 8H2O liquid. Auto catalyst Mn2 plus product catalyze the reaction. Separation of copper complex. Now we got to section 5. Okay, so this is section 4's equations. Section separation and copper complex. Dissolution. Both processes are physical dissolution, not chemical reaction. CuSO4 dot 4H2O. SO4 2 minus. Formation of tetraamine Copper too complex. Cu H2O6 2 plus 4 NH3 plus, no, it gives H2O twice, 2 plus aqueous solution plus H2O. Pale blue, deep, royal blue. Section 6, copper cycle. Before I write these, I just need to just make sure. Okay, I guess it's okay. Dissolution of copper in nitric acid. So it's correct overall. Two percent. Okay. I just looked at my battery percent maybe 5 or 10 minutes ago. It was 30. I don't think it's 10 minutes. Maybe 5 minutes ago it was 30. Now it's 28. This guy is not taking his battery very well, brother. Brother, stay strong, brother. CuNO3 twice aqueous solution plus 2NO2 gas plus 2H2O liquid. Precipitation of copper to hydroxide. Copper to hydroxide. It's lagging. Let me. I'm thinking, should I restart the tablet? I think I should restart the tablet. No, stupid. Okay, I think it can restart it. Come on. Precipitation of copper to hydroxide, copper 2 plus aqueous plus. I mean, they're not showing the whole equation, right? C2 plus. Two OH minus. Nah, it does not make a difference. COH twice. Blue solution forms a blue precipitate. Decomposition of copper to oxide. Decomposition to copper to oxide. CuOH twice. Just heat. CuO plus. Blue precipitate turns black. Dissolution of oxide and sulfuric acid. H2SO4. CSO4 plus H2O. Now, black solid dissolves to form blue solution. Black solid to form blue solution. Production of copper ions by zinc. I mean, it's copper sulfate, right? Observation: blue solution fades, brown red copper metal precipitates. Right now, let me just write it. This copper ions by zinc. Cu2 plus. Serum 2 plus. Blue solution fades with brown slash red copper precipitates. Clono Pin Commander, how's it going? It's going okay, I guess. Yeah, I have to learn all the equations, and that's the hardest for that is the hardest part for me, learning, memorizing. So, well, let's start with section 4. Section 4. Hmm. You got this. The more time you spend studying, the more you learn. Yup. Focus, gotta focus. So let's do metals with acids and bases. Appreciate the support, Clonopin Commander. Really do appreciate it. I also need to see the time, how long I should spend on this. You know, when you know how much time you should spend, it makes you learn faster. 1:30 to 2:30. Learn. Okay, so I have time till 3. Okay, I have time till 3. 45 minutes. Hey Siri, set a timer till 3. That's exactly. That is exactly the time. Metals with acids and bases. Zinc with HCl, zinc solid plus HCl liquid. I guess zinc chloride. H2 gas, okay. Iron with sulfuric acid. Fe plus H2SO4. Aqueous solid. FeSO4. H2 gas, okay. Phi plus H2, so 4 aqueous. Aluminium with sodium hydroxide. Ale solid plus NaOH. Aqueous. Na ale OH thrice, 4 times. Three H2. Sodium aluminate. Again, zinc. Now iron with sodium hydrochloric acid. No, sulfuric acid. FeSO4 plus H2. Aluminium. With what? Sulfuric acid? No, sodium hydroxide. It's just Fe plus H2SO4, FeSO4 plus H2 gas, aluminium with sodium hydroxide, 2 times aluminium plus 2 times NaOH gives 2 times Na. OH 4 times. 3H2. Okay, I guess I do remember those three. Oxyhydrogen test. Nah, it does not matter. Does matter. You're a chemist in the making. Yes! Not just chemist, biochemist. Biochemist. Hell yeah. Okay. Aluminium with HCl. Oxy, hydrogen test. Six times HCl, goddamn. AlCl3, similar to zinc, but zinc has ZnCl2. Okay. Al with HCl, giving H2 gas. Aluminium plus HCl, yeah. Six times HCl gives 2 times AlCl3 plus 3H2O, H2. Okay. Again, repeat all the reactions. Zinc plus HCl, aluminium plus HCl, iron plus H2SO4, aluminium plus NaOH. Two times Al plus six times HCl gives 2 times AlCl3 plus 3 times H2. Fe plus H2SO4 gives Fe Al plus NaOH. Hey, oh, dude, I forgot. Wait. 2Al plus 2 NaOH. 2 NaAlOH 4 times plus 3H2. Okay, so those are done. Now, equation. Latex. Latex. Okay, whatever. Whatever. Okay, so it's the same thing. Mm-hmm. Redox, amphotericin, hydrogen peroxide. Two times iodine plus H2O2 plus 2H plus. I'm guessing that's from water. Oxidizing agent. As reducing agent. 2MnO4 minus 5 times H2O2 gives plus 6H plus 2Mn2 plus 5 times O2. Purple solution turns colorless, okay? Okay, now reducing agent. H2O2 as oxidizing agent. I2 plus 2H2O. 2I minus plus H2O2 gives I2 plus 2H2O. 2H plus, I keep forgetting the H plus. I2 plus 2H2O. H2O2 as reducing agent. Two times MnO4 minus plus 5 times H2O2. Let me clear the bladders. Get out, yeah. Oh, the batteries. Batteries about to be fucked up. Two MnO4, two MnO4, two MnO4, 2 minus plus 5 H2O2 plus 6H plus gives 2 Mn2 plus 5O2. 8H2O, okay, 8H2O. H2O, peroxide as oxidizing agent. I2, oh, I2 minus 2I2 minus plus H2O2 plus 2H plus I2 plus 2H2O. H2O2 as reducing agent. 2MnO format plus 5H2O2 plus 6H plus gives 2Mn2 plus 5O2 plus 8H2O. Yep. Now from the start, how many equations was there? Zinc plus HCl, aluminium plus HCl, iron with sulfuric acid, that's it. No, there's more than 3, right? H2SO4, aluminium with NaOH. Okay. Aluminium plus 3H plus H2SO4, F3SO4 plus H2, L plus 2 NaOH. Uh, 2 times NaL. Not gonna lie, that equation does not make sense. Okay, there was a 6H2O. Oh, so that was what I was thinking, yeah. H2O, okay. OH. So we got we got 4 times 2, 8, 2. Okay. 2 plus 6H2 goes. There's 6 left. 6H plus 3 times H2. Okay. Now, what was the next equation? Directly to, okay. Oxyhydrogen test. Amphoteric reaction. Hydrogen peroxide as oxidizing agent. I2. Two H2O. Two H plus. Yep. H2O2 as reducing agent. 2MnO4 2 minus plus 5H2O2 plus 6H plus gives Mn2 plus 2Mn2 plus 5O2 plus 8H2O, if I remember. To remember it by preparation of oxygen. There are two ways: combustion of thermal catalytic decomposition of peroxide and thermal decomposition of peroxide. So hydrogen peroxide under the influence of magnesium dioxide, okay. Catalyst. Water plus oxygen, okay. Just to make sure. Suggestions, favorites. I guess add favorites. Because I really need this. Why is it not here? Intro lab. Very, very difficult test. NH3 plus HCl. Okay. Intro lab course exam. NO2 is characteristic due to the brown, yellow. Experiment with potassium permanganate and C2O4. Ah, I forgot what it is. Oxalate, yeah. Redox reaction. Nope, not these. Nope. More salt. Bro Margarite. Bro Margarite. Hell yeah. Mm-hmm. That's a periodic table. Okay. Okay, I think this guy I don't want to read right now, but catalytic thermal decomposition. Potassium permanganate. 2K-MnO4. Heat. K2-MnO4. What's about Are you basically memorizing these reactions? Kinda. I wouldn't say memorizing. Yeah, I would say memorizing. Yeah. I actually, I was not focusing on the equations right now. I accidentally, what's it called? I was not focusing on this for a moment. Uh, but the thermal decomposition of potassium permanganate gives K2 MnO4. Wow, what is that? K2 MnO4. No way. Mhm. No, I see the point where I did not predict how timetable goes. According to the timetable, I should be done at 3 with these equations, but I'm not. I have time till 4 for this study session. 1:30, 2:30, 3:30, 4:30. I'll say 5. Yeah. Hey Siri, set a timer for 1 hour.
1 hour, counting down.
You know, it's been 1 hour, right? I should take a 15-minute break according to the timetable.
I found this on the web.
So I'll be back in 15 minutes, okay? Hey Siri, set a timer for 15 minutes.
15.
Yup. with the 15 minutes nap. I was doing till thermal decomposition of potassium permanganate. Yo, Devoto did appreciate for checking out the stream. Are you not on board? Yes, I am on board. I'm gonna refresh the chat. Oh, this nap technique is good. Thermal decomposition. Catalytic decomposition of peroxide. Two H2O. O2. Manganese dioxide catalyst. Catalytic decomposition. Catalyst 2H2O gas. H2O plus OH2. Okay, now thermal decomposition of KMnO4 giving oxygen. KMnO4 under heat gives K2MnO4 plus K2 plus MnO2, okay, magnesium oxide. That's O2 gas. Thermal decomposition of potassium permanganate. K2MnO4 plus MnO2, O2 gas. What kind of decomposition was for hydrogen peroxide? Was not thermal. Catalytic, yeah. Decomposition of peroxide H2O2 with MnO2 gives 2 times H2O plus O2. 2 times H2O plus O2. Thermal decomposition. For 2 KMNO4 heat K2 MNO4 plus MNO2 plus O2. So I kind of believe I know it. Let me see. Catalytic decomposition of hydrogen peroxide. Mm, 2H2O, SO2, thermal decomposition of potassium permangate, 2 times KMNO4 gives what? K2 MNO4 plus MNO2 plus what's left? O2? No, I don't think so. 8. Okay. 5, 6. 2O2. No, O2. There's no 2. Yep. Okay, that's done. Now, again, starting from the beginning. What are the equations? Zinc plus HCl. Aluminium plus HCl. Aluminium plus NaOH. Iron plus H2SO4. Auto. Oh no. Amphoteric. H2O2. Reactions. Oxidizing agent. Reducing agent. Catalytic decomposition, thermal decomposition. So zinc plus 2 HCO gives zinc chloride plus H2 gas. LCO3 plus 2H2. And aluminium plus sodium hydroxide aluminum plus sodium hydroxide oh I forgot, but I do remember. We got two aluminum, 2 NaOH. Two NaAlOH 4 times plus just 8. So we got 8 OH 2. So 6 H2O 2 12 plus 2 14, out of which 8 is taken. So 6H plus 3 H2. Fe plus H2SO4. FeSO4 plus H2 gas. Well, amphoteric properties of hydrogen peroxide. When it acts as oxidizing agent, 2I minus, I2 minus. H2O2. I2. H2O. I remember 5H2O2, 5O2, 6H2O. No, I don't remember the exact balancing. Okay, it's just 2H2O. Okay, that was... I went too far. The I2 plus H2O, 2H2O, 2H2O, I guess. H2O. Reducing agent. Peroxide acting as reducing agent. I forgot the equation. Mn2 plus 5O2 plus 6H2O. 8H2. Okay, okay. I just did not balance, but it was right. 2Mn2 plus. Devoto did appreciate for checking out the stream. And if you don't mind, I'm gonna refresh the chat. Cause it's too bad we can't see what you're writing on your tablet or paper. Oh. You know what? I could share it, but then I cannot refer this. You know? I think I have a solution. How does it look if I paste it to my notes? It's kind of readable. Yep, let me see. Oh yeah. It is readable, so I think I could change. Do I need anything? Nope. And how does it work? Whoa. What happened to the tablet? Okay. So this was wrong. Reducing agent. Hydrogen peroxide acting as a reducing agent. So it's 6H plus. How much? I forgot. You know what? Let me just balance it. 2Mn2 plus H2O. We got 6H plus 4O2. 6 8 10O2. 5. We got 10O2. shoot. Oh, I remember now. 8H. 8. 8 2 are 16. 6. I believe that's correct. Yep. That was correct. Now, catalytic decomposition. Catalytic decomposition of peroxide, right? Yeah. Uh, mm-hmm. We got 2H2. Is that how it is? No, it's just 2O2. Just O2. Okay, two. We already got 4. Oh, it's 8. 4. Okay. Okay, I just missed that. Beep, 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 beep. So 2K MnO4 with heat MnO4 plus MnO2 plus O2. So it's not based on peroxide. This is for peroxide, and this is for potassium permanganate. Okay. Clone open commander. I'm reading the chat using my phone. Is this for inorganic chemistry class? I don't even remember doing these equations myself. I never took inorganic. Okay, so this is not inorganic. It's introductory lab, and this is part of section 4. I could tell you what it is. Let me see. This is part of section 4 where these are redox reaction. Some of the first reaction I okay. So redox amphoterism. Uh, One of the examples was hydrogen peroxide acting as oxidizing agent and reducing agent depending on the reactant, potassium iodide and potassium permanganate. Then I think the last two reactions were based on oxygen preparation, like formation of oxygen by thermal decomposition of potassium. Oh no, not this. Thermal decomposition of potassium permanganate. No, yeah, thermal decomposition of potassium permanganate. And what's the next one? Catalytic decomposition of hydrogen peroxide. Both should give oxygen. Yep, which helps us. This oxygen was in the experiment. We have to find out if oxygen is produced, and if the oxygen is produced, we would light up a wooden stick, something looking like this, a wooden stick, and put that wooden stick into the test tube where this reaction occurs. And if the wooden stick still burns, like we put it inside the test tube after burning the tip, and when we put it in inside the test tube, if the stick continues to burn, that means oxygen is produced. And I think for both of these cases, the wooden stick kept on burning. So I think that's where these reactions occur. Yep, that's where these reactions occur. Now, what else? What else? Autocatalytic reduction of potassium permanganate by oxalic acid. Can I take the notes from here? Oh, I can. Okay. That is actually pretty cool. Catalytic reduction. Cool experiment. Yeah, it was cool, but when I was on the lab, I was pretty slow, and I did this wooden stick into the test tube part I rushed the whole experiment. But yeah, it was cool. At least it was cool to see how these reactions happen in the real world. Reduction of KMNO4 by oxalic acid. Oh goddamn, oxalic acid is one weird 6H plus. Okay, that's what leads to autocatalysis. Mm-hmm. Yep, that's for section 4. Okay. There's no 2, god damn it. Just 2 minus 5H2C2O4 6H plus gives I could balance these equations during the exam time, but it's better to learn what comes next, I guess. H2 of C2O4 plus 6H plus gives 2Mn2 plus CO2 plus 8H2O. 5H2C2. So CO2 plus H2O, CO2 plus H2O. Those are one of the main products. Mhm. Just so you know, you'll forget these reactions by the time you're in the job. I know, but it's good for introductory chemistry. I guess these reactions are actually a lot more complicated than it's made out to be at the quantum level. I like your handwriting style. Oh, dude, this is my fast handwriting. I really appreciate that. And yeah, I mean, when I was when I was in school, I always felt like, what is this reaction? Wait, how do you know uh, this amount of carbon, this amount of hydrogen are involved in these reactions? You know, I think that's for now. It's a good way to represent. I think it's a good way to represent what's happening, I guess. And yeah, I have to take my phone every time to see the comments, like the chat, because when I share my tablet screen, everything goes blank. I could see my tablet screen here, and my laptop is basically useless. My laptop screen is just black. So, yeah, sometimes I might see the comment a bit late. Apologize for that. I really do. You know what? Just so you said that, I want to know if there's an option to see the chat. Nah, there's no option. There's no option other than just taking. Again, with the eyes closed, don't see that. Okay, that's just 2 MnO4 minus plus. What's it? 5 times C2H2. Oh, you start with H. You start with H2 C2O4 plus 6H plus gives 2 Mn2 plus 10 CO2 plus 8 H2O. Oh shit. Okay. Okay. So this is the auto catalyst. Again, the whole reaction involved in section 4. Zinc plus HCl, aluminium plus HCl, aluminum, aluminium, iron plus H2SO4. Okay. Amphoteric peroxide. Okay. Oh shit, I forgot. I forgot the amphoteric reaction. I think the oxidizing agent was iodine. Reducing agent was permanganate. Permanganate plus no. Shit. My mind is saying it's permanganate, but permanganate is for this was for the catalytic decomposition. That was also H peroxide, but thermal decomposition. That was potassium permanganate. What else? Okay, then we're going to autocatalytic reduction. Autocatalytic reduction of mm-hmm. Mm, 2Al plus 2NaOH 2NaOH times 4 plus, god damn it, I forgot. We got we got 8 oxygen. I forgot one important thing. 6H2O. I forgot the 6H2O gives now. Now is the real hard part. What's the remaining? We got 2 6 to 12 12 plus 2, 14, out of which uh, 8 was just here, so it's 6, 3H2. If E plus H is a 4 gives if E is a 4 plus H2. They all release hydrogen. I2 minus plus H2O2 gives I2 plus H2O. Wait, we got, we got. I'm thinking if there's a H plus on the left side. Who knows? Who knows? Who knows, right? No problem. It's good that you're focused. We need to pull up those grades. Pull those grades up. Hell yeah. And you know, I wish they asked these equations. That's the most important. Please ask for the exam. That's it. I guess it's time to play some music. Come on. Wait. MNO 4 minus MN 2 plus. Damn, it's been 1 hour. Hey Siri, set a timer for 1 hour.
1 hour, counting down.
Oh, come on, just. I know there's water and oxygen. I haven't looked into the half half reaction of the amphoteric property by peroxide. Two, two, 4, 4, 2, 2. Yeah. Thermal decomposition. Nope. Mm. Oh, yeah. Macht Sinn. Jo. Jo, das macht Sinn. Jo. Now, autocatalytic reduction of potassium permanganate, MnO4 minus plus 5H2C2O4 plus. God damn it, I forgot. There was 6H plus. I forgot. I do remember. Mn2 plus. 2 Mn2 plus. 2 10 CO2 plus 8 H2O or 6 H2O. Let me see. Oh, okay. We were almost correct. It was just this part I was. What I forgot, the hydrogen peroxide acting as an oxidizing agent. Okay, 2H2O. Oh, that's it. Okay. Reducing agent. Oh no. Oh no, I messed up so bad. 6H plus. 2, right? 2. 2, 2, 8, 5. Right? 5H2O. No, 8H2O. Well, these are the equations for section 4. Oh lord. Yep. Now the question is, should I move on with the next or should I master these? I think it's better first to move on, just to get all the others into my head. Section 5. Okay, the first one doesn't matter. Formation of tetraamine copper. Okay, copper, hydrogen, copper water complex. I don't know. H2O. Damn, that's a weird equation. 4 times ammonia gives CuNH3 or H2O2. Plus 4 H2O. Oh, then it's section 6. Okay, that's cool. Section 6, that's the most important because I know they're gonna ask a question from that. Come on, bro. Well, let me go clear the bladder up. Be right back. Some water. Let me. Pale blue to deep royal blue. I don't know if you could see that jitter, you know, whenever I write something. Okay, now it's working pretty good, but yeah, I wrote an M, but it came a bit late. That's not the stream's problem, that is the tablet is slow. It's an old tablet. Let me try to write by looking at the screen. I can. Okay, that's a cool idea. Let me try to write by looking at the screen. 4H2O. Ah, okay. I believe them. So it goes from pale blue to oil blue color. It's doable. Okay. No, that's too high. Is there an option to see the tip? Now. Yep. So CuH2O6 plus 4 ammonia. CuNH3 H2O 4 times. So ammonia took over 4. I missed that number. Where is it? Two plus. So it formation of tetramine copper 2 complex. Once more. Once more. Equals plus 4 NH3 I don't get it. So we got 6H2O. Oh, okay. No. 6H2O. How does it become 4H2O? The numbers don't add up. Should be 2H2O. Yep. I need to check that. What's wrong with that there? No way. I'm tripping. I saw 4. Okay. Okay. Okay, I yield. Okay. So it's all wrong. Six, 2. I missed the 2 plus, okay. Well, that's just how it is, right? Whoa, 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 whoa. Whoa. Oh, I forgot the pencil is about to run out. Yep, the pencil's battery is about to run out. Let me check. Yep, the pencil's dead. I guess I have to keep the pencil charging and move on to something else. Will you be there? Okay. Dichloromethane. Iodine, acetone, sucrose. That's it? Okay. Acetone, water, recrystallization, benzoic acid, irritation to eyes, respiratory system, and skin. Avoid creating dust, wear gloves, hydrochloric acid, causes severe skin burns, eye damage. Uh, Sublimation produce toxic vapors, ethanol, highly flammable, hydrochloric acid, nitric acid, strong oxidizer, corrosive, causes severe burns, reacts violently with nitrogen gas or fumes are toxic. Sulfuric acid, very corrosive, causes severe burns. Sodium hydroxide, corrosive, severe skin burns, eye damage. Oh, I'm still on this camera, right? I forgot about that. You know, I discovered another feature my computer has. What? What the? So class, today we're gonna talk about Hydrogen peroxide. It causes skin cancer and eye irritation. It is a very dangerous compound. Be careful, people. Don't fall for this. Now let's go for po- potassium permanganate. It's a strong oxidizer. Oh shit. Can cause fire upon contact with combustible materials. So you know how it is. It's bad. Oh, whoa, whoa. Manganese. It's initiating in respiratory system, irritating in respiratory system. Don't breathe this. Now, zinc. It's flammable and release flammable hydrogen gas. So don't fuck with this. Zinc dust. That shit crazy. Now for aluminium, its powder is flammable, and releases hydrogen gas. Yeah, that's yeah, yeah, it's fun. Separation and copper complex. Benzyl. It causes eye and skin irritation. Don't wear this. Copper sulfate. Harmful if swallowed, toxic to aquatic life. So don't eat this. Ethyl acetate. Highly flammable. Vapors vapors cause drowsiness and dizziness. So if you want to get high, you could take ethyl acetate. That's a good choice. Ammonia. I did inhale ammonia. Oh shit, that was. It's highly corrosive and irritation to eyes and respiratory tracts. So if you wanna feel really weird, you could smoke some ammonia. That's one of the weirdest thing I ever inhaled. We got nitric acid. Where is it? Yeah, it's corrosive and oxidizing. Produces toxic brown or what gas? Nitrogen gas. Don't smoke it, please, people. Don't do this. Sodium hydroxide. This is not sodium chloride. It's sodium hydroxide. It's corrosive. So don't bring it near anything. Sulfuric acid, same corrosive, corrosive. Yeah, corrosive. The fuck am I doing? Zinc dust. It's flammable. It's a solid and reacts to release hydrogen gas. So it releases a gas that inhibits. No, that no. What's the opposite for inhibit? That supports fire. So don't fuck with this. Hydrochloric acid. Yep, don't fuck with this. Think that's it. We got corrosive. We got the compounds that are corrosive are hydrochloric acid, nitric acid, sulfuric acid, sodium hydroxide, ammonia, ammonia solution. Okay, these causes severe burns. Now flammable, acetone, ethanol, ethyl acetate, zinc dust, aluminium powder. Keep away from flames. Okay, though these catch fire. Now what else? Toxic. Dichloromethane. Don't do this. Iodine. Nitrogen gas. Ammonia. Oh, ammonia. You gotta smoke at least ammonia once in your life. I recommend you people. You gotta do it. That was. I felt like half of my brain just shut off. That was amazing. Now we got oxidized. Oh, what is that? Oh, that's my bag. Okay, we got oxidizing agents. That's nitric acid, hydrogen peroxide. Hydrogen peroxide, what's this? Potassium permanganate. These causes fire. Okay. Now toxic, general. Copper salts, these are toxic. And iodine. Okay. That was a fun use of this. You know, I could use this video format to explain stuff. You know, I could use this to make shorts. YouTube shorts. But yeah, these are options. Presenters overlay small. Oh no, I'm here. I got to the small space. Okay. Yeah, it is funny. It's it was real fun to use that form. Oh, I still can use my hands. Okay, so just to a point. Um, so I'll start with the dichloromethane. How does this look? Because they do ask, how does these, what is its formula? So one chlorine is on the front, one hydrogen back. Okay. That's dichloromethane. Acetone. CH3COOH. That's acetic acid. Oh, okay. COCH3. So how does this thing looks? C double bond O CH3. Okay. Sucrose. Sucrose ain't doing it. Benzoic acid. So that's a benzene ring with the with the with the with this with the COOH. I can see why I'm not passing organic chemistry. Yeah. Was OOH. Oh, okay. You could write it this way. Oh, okay. There is a carbon here. Okay. Hydrochloric acid. I do know ethanol. Oh, ethanol is CH3, CH2, OH, right? Yeah. CH3, CH2, 5, OH. Okay. Hydrochloric acid, nitric acid. I do know how the structure looks like. Sulfuric acid. I do know. Hydrogen peroxide, potassium permanganate. I do know. I do know. Manganese 4 oxide. I do not know, but I do know how this looks. Copper 2 sulfate. Kupfer 2 Sulfat. CuSO4. 5H2O. Ethyl acetate. Not gonna lie, I don't know how that looks actually. Let me see how it looks. Why is there no paste in search? Wow. Ammonia solution. Ammonia clusum. Nitric acid, sodium hydroxide, sulfuric acid, zinc dust, hydrochloric acid. The more I think about it, please, when I said inhale not sodium hydroxide. When I said inhale ammonia, it was a joke, okay? If anyone's listening to this and thinking, "Oh, I should inhale some ammonia," please don't. That was a joke. I gotta say, I don't want no beef. That's it? No, there should be more. Let me see the question paper. So distinguishing of what? Of gases. Ah, hydrogen reacts positive in an oxyhydrogen test. You try to ignite the gas in the test tube. A, a pop sound. Oh, whoa! A pop. That was a pop. Indicates a mixture of oxygen and hydrogen. And a silent plop blop indicates higher concentration of hydrogen. Oxygen reactive positive in what? Reactive positive in a glowing splint test. You put a glowing splint in a test tube, it ignites if O2 is ignites in higher concentration if O2 is present. Now 1 plus 3, both are colorless gases. Nitrogen is a colorless gas. It is unreactive, so it will neither be positive in the oxyhydrogen test nor be in the glowing splint test. Okay. Oh, I think this question is based on how do these gases react on oxyhydrogen test and splint test, or distinguish the following gases. Now, nitrogen dioxide is a characteristic due to its brown yellow color. It is only one of the four with a color. Okay. Now, experiment with potassium permanganate and oxalate ion. That was, what was that? Come on, Joe, think, what was it? Whoa, this reaction is kind of different. 8H2O, 10CO2. Okay, that's correct. Why is it NaC2O4? It's supposed to be. Oh, here it's not hydrogen oxalate. It's okay. Okay, I guess this question could be coming. What was it? It was from section 4, last part of section 4. God damn it. What was it? Yep, it's autocatalytic reduction. Autocatalytic reduction. Okay, autocatalytic reduction of by oxalic acid. Okay. So I don't know if there's no autocatalytic reduction mentioned here, but now what's next? Iron 2 diode. Iron 2 chloride? Yeah. Iron chloride preparation. Hexachloride. Math! There's math! Oh, I forgot the math section. exactly 2.70 grams of 0.05 moles of iron 2 chloride solution. Iron 2 chloride hydrogen. What is this guy? Hexahydrated. Hexahydrated? What? R. R. Light. Weighed in a balance into a 100 milliliter beaker. The solid is dissolved in 50 milliliter deionized water and transferred into a funnel, into a volumetric flask and beaker, and the phenyl as 4 times with deionized water. The flask is filled to about 3/4 closed and shake to 2 hours. Then the flask is filled with below the mark. Shake 2 times again. Then the flask is filled till the meniscus is reached and shade the 2 times again. Then some drops are added till the meniscus is reached again and the flask is shaked one last time. For what? It's iron to prepare. Usually I use the volumetric flask for a sugar solution preparation. It was not for the iron. But yeah, whatever. Now what is this? Combined? Complete neutralization cause extraction. Extraction is a method to extract a certain substance out of a solvent, letting the impurities in in that solvent, transferring the substance wanted in other solvent. Both solvents have to be miscible. The transferring is based on the I could search up the upper phase is one with the lower density and lower phase is one with the higher density. And it's usually the aqueous phase, the inorganic phase is at the lower. Yeah. From my experience, the aqueous phase is at the lower. Not gonna lie, I'm pretty tired. So, again, 15-minute break or 10 minutes break. Peace. Just a 10-minute break and we'll be back. Not the reaction, the calculations. Recrystallization and sublimation formula. Yield percent is equal to mass of the pure product obtained by mass of the impure starting material into 100. Percentage recovery for sublimation. Mass of the sublimed item by mass of the impure mixture. Okay, these formulas are pretty easy. Mass of the pure benzyl obtained by mass of benzyl in the original mixture. Is this flickering noticeable on OBS? Yeah. What is wrong here? Did I turn on studio lighting? Oh, wait. Flickering so bad. Off. Okay, now it looks good. Mass of the pure complex obtained by theoretical mass of the complex. Yeah, these are all pure by theoretical mass or percentage yield. Mass of the pure benzyl. Now that's percentage yield for. Now that's a pretty. That's an equation there, right there. Percentage yield recovery for an entire cycle. Formula recovery percent equals final mass of copper divided by initial mass of copper. You start with 1 gram of copper wire. By the end, you recover 85 grams of copper wire powder. We get 85%. That's it. General calculation skills needed for all sections. Molarity equals moles of solute by liters of solution. I need to check on my timetable. What was my dinner? When should I have my dinner? Not gonna lie, this timetable is pretty good. It's not that frustrating. And I do remember when I started last year, I do remember preparing timetables, but last year it was like waking up on this time. It was not like what I have to do in this time frame. It's just I have to wake up at this time. I have to do study or cooking or whatever at these times. But look at me now. I am assigning each time frame a specific task. There are changes, I guess. Break. Break is from 4. Yep. This is the 1 hour break I get. And after the break, oh, my dinner is at night. It's at night. Between 8:30 and 9. Okay. Okay. Can I reading level, add final polish, add emoji, adjust the length. Suggest edits. Hello. It's pretty cool. It's pretty cool. Well, I think it's 5, right? I gotta take that break. I gotta take that 1 hour break. It's just I have to call my parents and I need to refresh my mind, I guess. So what am I gonna do after the break? I gotta learn the equations, the chemical reaction equations. Yep, this part. This part that's the main thing, and after that, I have to look into the toxicity and cool. I'm gonna go study myself now. Respect. I really appreciate that. From one brother to another. Respect. Okay. Well, that's it. I really hope the studying goes well, Clone Open Commander. I'm gonna end the YouTube stream, but Twitch is gonna be just run.